Okay, I'm going to connect standard deviation with a normal distribution and two percentages of the population. Okay, so let's just start with what we did last time. Let's say the mean of a test was 80 with a standard deviation of 5. Okay, so how we connect this, well, let's do this first. There's standard deviation notation, which you'll see, which is this. X, that's a tilde, bracket, and it goes mean, comma, standard deviation squared. So if we had a mean of 80 and a standard deviation like this, the notation would look like this. It would be 80, comma, 5 squared. So you only take the 5, just as this is the standard deviation. Here's 5, and then the 80 comes from there. So standard deviation notation, I would write this down somewhere to remember. Okay, write that down so you can remember it. But when you see it, it's going to be sometimes written like this. And it's just telling you the tilde is kind of an approximate. So it's giving you an approximate, set up a approximate normal curve here. Okay. So if we remember, the mean happens in the middle. So that's 80. And we're going to plus and minus the standard deviation all the way across here. So here's 85. Here is 90. Here's 95. Then we're going to subtract on this side. 75, 70, and 65. Okay? So that's how we set up a normal distribution with standard deviation and a mean. Okay? But what's this tell you? That's the question here. And then we're going to apply it to percentages. So what does it tell you? So if this was a test, and we took away this here, along this axis here would be the number of people, the number of students. And this would be marks. This would be 65, 70, 75, 80, 85, 90, 95, which would show us very few people got 95 and 65. A lot of people got 80. Less people got 75 and 85, 70 and 90, same thing. Okay. So the way we can use this to make estimations is in a normal curve, there is a certain population that resides within each standard deviation point over numerous, like over thousands of normal curves. This average has bared out. Now, is it perfect every time? No, that's why it's approximate. Okay. So, actually, I'm going to go down here first, and I'm going to go up there. So I'm going to rewrite the numbers we just had there. So we had 80 in the middle, and we went up by 5 every time. 85, 90, 95, and then 80, 80, 75, 70, and 65. Okay. So here are the numbers, and I'll go through this after with you. You need to memorize these numbers here. Almost the most important numbers you'll see all the way through. So if I ask the question, what percent of the population, what percent of the class got between a 75 and an 85? Okay. I would look and I'd say, okay, between 75 and 85 is this section here. So always between the mean and one standard deviation apart on either side, there are 34% on each side. So if I go 34 plus 34, that would mean 68% of the people that wrote the test got within that. Now, if I asked a question like, what percent got below 70, I would go to 70 here, and I go, what's below? So that would be 2.35 plus 0.15, which would be for 2.5%, correct? Yes. So 2.5% of the population of the class got below 70% on the test. And you kind of play with these numbers here. So let's go, what percent got above a 75? So above a 75 would be all this section up here. So that would be, where should I do this? I'll do it up here. 34 plus 34 plus 13.5 plus 2.35 plus 0.15. All right, so let me do that math real quick. 68 plus 13.5 plus 84% of the 84% of the class. Okay, so within a normal curve, these percentages hold true. Okay, now what decimal place you go to, this is by 0.35. This is the one decimal place. So like these don't exactly match. The one before was 0.35. This is just an estimate. Okay, so whether you use 2.5 or 2.35, you're going to get approximately the same number. These are not for exact percentages, they're for an estimate. So take your time right now, make a note on this curve. Okay, so these are the numbers you have to remember for questions coming up. So what this means is, on average, within one standard deviation point above and below, there's 34% of the data. So that means between here and here is 68% of the population. And then, because the curve goes down, the next stretch from 1 to 2 is 13.5. What's that? So between here and here resides 95% of the population. And then as we go out, another 2.5 and 0.15. Okay? So let's just play with this. We're going to do a bunch of questions. I'm going to keep asking you. Let's put our curve in. Okay. So what if I could give you this. Let's see. So let's translate that first. What's our mean and what's our standard deviation? Well, in this case, our mean is going to be, what color was used, right? 58. So this is the average height of people. So average height of people is 58 inches. And the standard deviation is 3. Okay. So now we can build our curve here. So we have 58 here. Now if we're going to go, I'm going up, I'm going to add 3 every time. So I'm at 61, 64, and 67. And on the way down, I'm going to subtract. So I have 55, 52, and 49. So then we can start asking questions along the lines of, what percent of the population, what sizes encompasses 68% of the height? Let's say this is height of students at school, at your school. So what, in between what height is 68% of the population. Well, that would be between 55 and 61. 34 plus 34. Right? Now I could ask a question along the lines of, this is my favorite question. What heights represent 81.5% of the population? Now this has two answers. Okay. What heights are 81.5? So the way we look at that is what numbers add up to 81.5? If you look here, 34 plus 34 plus 13.5 adds up to 81.5. So you would say 55 to 64. But also, this also adds up. It's still 34, 34, 13.5. So 61 through 52 also add up to 81.5% of the population. Okay. Now I could ask you also, what height is, I could ask what percentage of the population is below, let's use different colors. So what percentage of the population is below 61 inches? And that would be from, so if I'm talking below, I'm talking this way, which would be 68 plus 13.5 plus 2.35 plus 84% below. And then above, that doesn't work out. That should be a higher number. Oh, I forgot the other 13.5. 97.5. And above 61 would be the 2.5%. Okay? So let's do another one. Oops. One second here. All right. So let's do one more of these. I'll give you this. All right. So pause the video and try to make your curve for this situation. This is my mean. This is my standard deviation. So I'm going to put 100 in the middle. So it'll be 110, 120, 130 with a 90, an 80, and a 70. Good. Now let's ask some questions. So what percentage is, let me think here, between 110 and 130? So what percentage of the population is between 110 and 130? And that would be approximately 16%. I actually got 15.85. We'll go 16%. Okay. What else covers 16%? What two numbers would have 16% of the population between them? And that would be here between these two. Oops. Right? 90 and 70. All right, let's build another one. So what happened? What would you do if, I want you to fill this in this time. I want you to fill these numbers in for me. If I gave you something look like this, let's go with a 60 right there. I put 66 right there. I apologize. You hear my dog walking around. She's a golden retriever who likes to bring me things that she's not supposed to have just to get pet, just so I take it out of her mouth. All right, so pause the video there and see if you can fill in the numbers, then work from there. So if I take a look here, I got 6 here, right? So I have to figure out what numbers go in here, and if I count evenly, I'd have a 62, a 64, and that'd be a 68, and that would be a 58 and a 56, which would lead me to put a 62 here and a 2 right there. Okay? I'm trying to make sure I have all your questions that I'm going to ask you about. Shoot. Let me do one more here. I think you kind of have the idea of it. Let me do one more just to make sure. Looking up your questions to make sure I asked the right items. So wait for my other computer to log up. Let me see here. Let me look at the last question, make sure we can do that. No. No, I think we're good. So, no, I like where we're at. I think we're good. I don't think we need to do, well, let's do a word problem. Let me get my, let's say, all right, here we go. At the Dr. Pepper plant, I don't think that's how you spell bottling, but I'll go with it. So, Dr. Pepper plant cans are filled on average to a volume of 59.5 milliliters. The standard deviation of 0.4 milliliters. All right. And we'll build a couple questions off that. So what volume is 68% of the cans produced between? Can cannot hold more than 260.3. There we go. My wording on B is going to be a little odd. As in 260.3 seals, but 260.31 will fail. Okay? So, take a second and put your numbers on, or pause the video, and I'll do it in a second here. Put your numbers on, and then see if you can answer those questions. Okay, I'm going to do here 290, 259.5. So that's 259.9, 259, 260.3, 260.7. Then down here, it's going to be 259.1, 258 point. What's the standard deviation? 0.7 and 258.3, if I'm not mistaken. Good. So question A, what? Oh, that's got a good thing now. So question A is what two volumes? So we're looking at 68% is here. So that would be between 259.1 and 259.9. And for this one here, it would be this section here, which would be, what do we say, 2.5%. And boom. So big takeaway here is, oh, where's my stuff? Know your notation. Know these percentages, and I don't care if you use 2.5, I'm perfectly fine with that. And know the notation. Okay. Remember, the standard deviation is not squared, it's the number that's down there. For example, this would be 80, 4, but 4 is your standard deviation, and your mean would be 80. Okay, so pause her there, make sure you have those notes, and we're good to go.